Hi everyone, this is the practice exam 4 video. I'm going to do as many problems as I guess have energy for. Practice exam 4, here we go. So number 1, it's asking true or false, all trinomials of this form are factorable. So please justify your answer. So I need to say true or false. I'll say false. And the justification, I can simply maybe come up with a trinomial that does not factor. So for example, x squared plus x plus 1 does not factor. That would be sufficient. So false, since it was asking true or false, and then some justification. Number 2, in your own words, why do we need plus and minus when taking the square root to solve? So it says, for example, if u squared equals d, why are the solutions u equals plus and minus d, root d, and not just u equals positive root d? So, because for a case like u squared equals 4, if I just had the square root of 4, then we'd miss the fact that also negative the square root of 4, if you square it, you also get 4. So I'll just say, in summary, we'd lose an answer. Okay. Number 3, it's saying, in your own words, where does the quadratic formula come from? That is, how do we algebraically get from this equation to this formula that solves this equation? So what we do is we solve ax squared plus bx plus c equals 0 by completing the square. In general. Out of that process comes the solutions that are the quadratic formula. Okay, so that's page 1. Let's go on to number 4. So solve, it says leave your answer or answers in simplified radical form. So what I want to do on these types is isolate the thing that's being squared. That way I can apply a square root to undo that squared. So add 10, start there. We have 5 times x minus 5 squared equals 100 now. Divide by 5. Again, I'm still just trying to get this thing that's being squared alone. So x minus 5 all squared equals 20. And at this step, I take that square root, making sure I use plus and minus. So these would cancel, and I would have just x minus 5 now equals plus and minus. And if I type in root 20 to the calculator, it will give me a simplification. So if I have root 20, that's the same as 2 root 5, but I'll explain why that is. So 20 has a perfect square in it, the 4 specifically. Once you identify that perfect square, you can use the product rule to split across that multiplication. So x minus 5 equals plus and minus the square root of 4 times the square root of 5. So this is where that 2 root 5 is coming from. So I'll have x minus 5 equals plus and minus 2 root 5. And then just one more step is to add 5. So the solutions would be x equals 5 plus and minus 2 root 5. You could also split those answers up. You could say x equals 5 plus 2 root 5 and x equals 5 minus 2 root 5. All right, so number 5. It says, again, solve, leave your answers in simplified radical form. So just like the previous one, I want to get this thing that's being squared isolated. So I'll subtract 1 first. So we get 3x plus 1 all squared equals negative 12. Divide by 3. So I have x plus 1 all squared equals negative 4. And I'll take the square root, plus and minus. So these do cancel. And we have x plus 1 equals plus and minus. So the square root of negative 4, again, if you have this type of calculator, what you want to see is CMPLX up there. So if you don't see that up there, you want to go mode setup and then press number 2. So if I type in the square root of negative 4 now, it'll actually give me something, this imaginary number. But just to explain why, it would be the same as negative 1 times 4. Again, using the product rule, I can say x plus 1 equals plus and minus the square root of negative 1 times the square root of 4. The square root of negative 1 is that imaginary unit I. So we have x plus 1 equals plus and minus I root 4. The square root of 4 is simply 2. So x plus 1 equals plus and minus. It's typical to write the 2 out front of the I. And then simply subtract 1. So x equals negative 1 plus and minus 2i. Of course, you can check all these. I'm trying not to speed too quickly, but I'm kind of going through this a little more quickly than checking. So I do encourage you to check these. You would plug one of these or both back in for x and see that you do indeed get negative 11 on the left. So number 6, it says solve, leave your answer or answers in simplified radical form. This one is not factored right out of the gate. So one thing I can do is either look for a factorization or I can just go straight to the quadratic formula. So to use the quadratic formula, we need ax squared plus bx plus c set equal to 0. Right? When that's the case, your solutions are x equals opposite of b plus and minus the square root b squared minus 4ac all over 2a. So in this particular case, I have a as 2, b as negative 1, and c as negative 1. So we would have our solutions x as the opposite of negative 1, in other words 1, plus and minus the square root of negative 1 squared minus 4 times 2 times negative 1, all over 2 times 2. I'll simplify this by hand. So x equals 1 plus and minus the square root. This is 1, and then this will turn into plus 8. So this is the square root of 9 in there over 4. So in other words, we get 1 plus and minus 3 over 4. So if I take the plus case, I would get 1 plus 3 over 4, in other words 1. If I take the minus case, 1 minus 3 over 4, this is negative 1/2. Okay? On to number 7. Again, looks like it's already set to 0. This is kind of set up to either do the quadratic formula or factoring and then the zero product property. Let's see what I want to do. So -12, playing through it, 6 and 2, 4 and 3. I'm just going to use the quadratic formula again. So I'd have an a of 1, a b of -7, and a c of -12. So our solutions x would come in the form opposite of b, in other words, +7, plus and minus the square root of -7 squared minus 4 times a times c, all over 2 times 1. On this one, I'll just go ahead and use the calculator. Okay, so fraction first, and then it's 7 plus the square root of -7 squared minus 4 times 1 times -12 over 2 times 1. So I'm getting this as one of my solutions. So x equals 7 plus root 97 over 2. And then if I go back and change the plus case to the minus case, I'm going to get 7 minus root 97 over 2. Kind of a strange answer, so I'll go ahead and check this one. So this is already stored in memory, so I can go ahead and say answer, which is this button down here. So answer squared, I'm now plugging this one back into the function. So answer squared minus 7 times answer minus 12. I'm hoping for 0 or else something went wrong, but this looks good. All right, solve, leave your answer or answers in simplified radical form again. Let's see if this one factors. I haven't done factoring yet. I don't know if it factors, but let's see. I have an a of 1, a c of -8, so a times c would be -8. Factor -8, trying to add up to a 4. So let's see, I'd have 4 and 2, that's not going to work. 8 and 1 is not going to work. It doesn't look like this thing factors, in other words. Okay, so for that reason, I'll again just use the quadratic formula. That thing always works, the quadratic formula. So a is 1, b is 4, c is -8. So I'll get my solutions as x equals opposite of 4 plus and minus the square root, 4 squared minus 4 times a times c, all over 2 times 1. Okay, I'll use the calculator again. So fraction, -4 plus square root of 4 squared minus 4 times a times c, 2 times 1. So -2 plus 2 root 3. And then if we go back and just change that to minus, we'll get that other case. So it'd be -2 minus 2 root 3. It's always in conjugate pairs, actually, if you're noticing that. All right, these conjugate pairs. Conjugate pairs here as well. All right, on to number 9. So if I were to kind of say, oh, let me see if this factors, then we'd have our a times c method equals 3 times negative 12. Oops, negative 12 equals negative 36. Looking for numbers that add up to 5 if possible. So in this case, negative 4 and 9. Right, so negative 4 times 9 is negative 36, negative 4 plus 9 is 5, so this thing does factor. Since a is not 1, I can't quickly write down the factorization. I would need to go through this grouping stage. Keep in mind, I can definitely use the quadratic formula for this. I'm just switching it up to remind us about factoring a bit. So split up that middle term. So we still have 3x squared, and now I'll have minus 4x plus 9x minus 12 equals 0. Right, so we bring those numbers over here as coefficients, and now we factor by grouping. I'll factor this group, and I'll factor this group. So factoring out what's in common there, we have an x in common, 3x minus 4. Then I have a 3 in common here, leaving behind a 3x minus 4 again. And now factor out the 3x minus 4, leaving behind x plus 3. Now zero product property says that 3x minus 4 needs to be 0, or x plus 3 needs to be 0. And solving these. So add 4, subtract 3. So now we're here. We have 3x equals 4, or x equals negative 3, and that'll be one of our answers actually. Oops. X equals negative 3. And now just divide by 3 on this one. So x would equal 4/3, and also x equals negative 3. All right, next page. So number 10 says a paper airplane's height. So a paper airplane's height above ground h in feet as a function of its horizontal distance from the base of the house x, also in feet, can be represented by this function. It says, according to this function, how far did the plane fly before hitting the ground? Round your answer to 2 decimal places. Okay. So if the plane hit the ground, then that means its height is 0. So I'll plug in a 0 there as a first step. This is one of our equations that is not quite quadratic. So what we want to do is make a substitution so that this thing is reduced down to a quadratic equation. So I will choose to let u equal x minus 2 all squared. That would result in u squared equaling x minus 2 to the 4th. So where I have this x minus 2 to the 4th, I'll now have a u squared. It'll be negative u squared. And then where I have x minus 2 squared, I'll just have a u. So 0 equals negative u squared plus u plus 20. Okay. Looks like I can factor this one. So a times c would be negative 20. Factoring negative 20 and hoping to add up to a 1. I have a 5 and a negative 4. We do not have that a is 1. A is actually negative 1, so I do need to be careful and go through these grouping steps. So 0 equals negative u squared minus 4u plus 5u plus 20. And now factor by grouping. This group, this group. So 0 equals, I'll factor out a negative u. So negative u, leaving behind a u plus 4. Factor out a 5, leaving behind a u plus 4. Factor out u plus 4. So 0 equals u plus 4 times negative u plus 5. So it must be that u plus 4 is 0, or negative u plus 5 is 0. So that would mean that just adding and subtracting here, that we're getting u equals negative 4 and or u equals 5 from this one. This is a realistic scenario in which we're measuring distance. Okay, so what we want to do is actually go back to x's and then appreciate the fact that maybe some of these answers are not physically true, right? They might be mathematically true, just in a pure sense, but since we're measuring distance, we're not going to keep track of negative distance. So what I now want to do is go back to x's. So u was equal to x minus 2 all squared. So I need to go back there. So I'll have x minus 2 all squared equals negative 4. And then from this one I'll have, sorry, that's an x minus 2 squared equals 5. So this one will not be real. That's an imaginary solution, right? Something squared equals negative, that's not real at all. Take the square root of this one, plus and minus technically, but then I'm going to throw out the minus since this is distance. So I'd have x minus 2 equals the square root of 5, and then add 2. So in other words, x equals 2 plus root 5. That would be the exact distance in feet. It's said to round to 2 decimal places. So I'll take 2 plus root 5 and then press S to D here. So it's 4.236. So to 2 decimal places, this 6 rounds up the 3, and that 3 becomes a 4. So I'll have x equals about 4.24 feet. Okay, here's a very similar one, number 11. So a paper airplane's height above ground, all the same stuff, except we have this new function. According to this function, how far did the plane go before hitting the ground? So again, I'll set h equal to 0 because this thing is hitting the ground at the moment we care about it. I'll go ahead and let u equal x squared in this case. It's always this middle thing, basically. That would mean that u squared equals x to the 4th. Okay, so I'll make those substitutions. We'd have 0 equals negative u squared plus u plus 30. I'll go ahead and use the quadratic formula this time. I believe it does factor, but let's just go ahead and use the quadratic formula. I have an a of negative 1, a b of 1, and a c of 30. So u would equal, right, not x, but our variable here is u, the opposite of b, so opposite of negative 1, plus and minus the square root of 1 squared minus 4 times negative 1 times 30, all over 2 times negative 1. Calculator time, so I'll start with that fraction button. Negative 1 plus the square root of 1 squared minus 4 times negative 1 times 30 over 2 times negative 1. This will be our first u. So u equals negative 5, or I need to scroll back and change that plus to a minus. So I get a 6. Going back to x's now, right? I basically use this substitution in reverse. So we're wondering when x squared equals -5 or when x squared equals 6. Again, this one is not going to produce real solutions. This one will produce a real solution. So I'll go ahead and take the square root plus and minus technically, but I'll throw out the minus since we're again measuring distance. So x would be equal to the square root of 6. I said again, round to 2 decimal places. So square root of 6 and then s to d, 2 decimals, meaning this 9 is going to bump that 4 up to a 5. So we'll have 2.45. That is a number of feet. Sorry, there it is. Okay, on to number 12. Need some water. Okay. It says a stone is dropped from a 300-foot platform. The quadratic function h of t equals -16t squared plus 300 models the height h in feet of the stone with respect to time t. Time is measured in seconds according to this. It says how long until the stone is 100 feet above the ground. So different from the previous couple, right? We cared about when this plane hit the ground. Here, we, for some reason, care about when this thing is 100 feet above ground. So rather than plugging in 0 here, like we did previously, I'm going to plug in 100 here. So I'll have 100 equals -16t squared plus 300. And I want to solve this for t, meaning I want to isolate t squared. That's one way of doing this. So I'll go ahead and subtract 300. We would have -200 equals -16t squared. Again, we're isolating t squared, so divide by -16. I'm gonna type that in real quick just to get helped out with the arithmetic. This -200 over 16, let's see what that is. -200 over -16 reduces down to 25 halves. So I have 25 halves equals t squared. Okay, square root, plus and minus. We're solving for a time, so it's not going to make sense to talk about negative time. So if I square root, I still have this number on the screen, so I can go square root answer. It reduces down to 5 root 2 over 2. So I have 5 root 2 over 2 equals t. So that's how long. It doesn't say to round. If you're curious about what amount of time that is, it's about this amount of time. Okay, but since nothing was said about rounding, I'm just going to leave it in exact form there. How long until the stone hits the ground? Well, now we are concerned about when this thing is 0 feet above the ground, so I'll plug in that 0. All right, solve this for t. I'll subtract over 300. So -300 equals -16t squared. Divide by -16. So -300 over -16 is 75/4. So I'll write that down. So 75/4 equals t squared. Take a square root. Plus and minus. Again, I'm throwing out this minus because we're talking time still. I still have this on my screen, so I can go square root of answer is 5 root 3 over 2. So 5 root 3 over 2 equals that time. That's how much time. If you're curious, it should be a little bit more time because now it's actually hitting the ground. But again, it didn't ask for any amount of rounding, so I'm just leaving it in exact form. All right, number 13. So it says a giant rectangular lawn has an area of 1,550 square yards. Its length is 5 times the width. What are the length and the width of the lawn? So I'll start by just drawing a rectangle just to start seeing something. This area in here is this 1550, right? We have this relationship that says its length is 5 times the width. So if this is L and this is W, there's a relationship. I can say L is 5 times W, right? Just from that sentence. The area of a rectangle is length times width. So instead of having all these unknowns, well, we know the area we want. It's this 1550. And then if that's equal to length times width, something I can do is replace L with 5W. And then I'll have this quadratic in the variable W. So 1550 equals 5W times W. In other words, 1550 equals 5W squared. Isolate the thing that's being squared. So 1550 divided by 5 is 310. So 310 equals W squared. Take a square root. Again, plus and minus technically, but we're measuring the width of a rectangle, so it's not going to be a negative width. Square root answer. Sorry. So I had 310 previously. So what I mean is this was on the previous screen, so I can go square root answer, and that'll be actually the answer for W. So apparently this doesn't reduce any further. The square root of 310, this would be a number of yards. This would be equal to the width. If you're curious, it's about 17.6 yards. But again, there was no statement about rounding, so I'm leaving it in exact form. The length is equal to 5 times that. So in other words, I'd have 5 root 310. That's the number of yards for the length. So what are the length and width of the lawn? They're these. A way to check that is if I multiply those together, I should get 1550. So if I take root 310 and then multiply by 5 times root 310, I should get this 1550 to appear. Okay, on to number 14. It says a businessman took a small airplane for a quick flight up the coast for a lunch meeting and then returned home. It says the plane flew a total of 4 hours, and each way the trip was 200 miles. What was the speed of the wind that affected the plane that was flying at a speed of 120 miles per hour? Okay, so we have these kind of two parts of the trip. For both parts, it's d equals r times t. That's kind of this governing function. So I'm going to define kind of going up as the first part, coming back, that second part. What I'll assume is that the wind is going this way. Okay. So for the first part of the trip, so going up, it would be a distance of 200 miles equals the rate that the plane is going. I kind of want these to be. So I'd have 200 equals the rate the plane is going plus, on the way up, the wind speed, right? Because the wind speed would be helping the plane on the way up. We'd have this tailwind. So I'd have 120, in other words, the speed of the plane, plus the rate of the wind, right? And then I would have times, maybe I'll just call it T1 for the time that it took to go up. For coming back, I'd have 200 miles to go. We'd still set the plane to go 120 miles per hour, but then on the way back, you can see the wind would be opposing us. We'd have this nose wind or headwind. So I'd subtract the rate of the wind and then multiply by some amount of time. Okay. This is one unknown, R sub W, that's the rate of the wind. So that's a total of one unknown. Here's another unknown, here's another unknown. So there are three unknowns here. There are only two equations. So we'd be stuck if I didn't have another equation, but we do know that it took a total of 4 hours. It doesn't mean that it went 4 hours up and 4 hours back, just some amount of time up, some amount of time back, and all that we know is that those two times add up to 4. So we also have that T1 plus T2 would equal 4. From that, if you subtract, let's say, T1, then you can write 4 minus T1 equals T2. And I can take this value and plug that in for T2 right here. Okay, so I'll go ahead and do that. So we would now have still this first equation, I'll just write it down, 120 plus R sub W times T1. And then instead of T2, I'll have, so still the 200, 120 minus R sub W. And then instead of T2, I'm going to write 4 minus T1. So now these two equations, if you look here, we have one unknown, right? R sub W is one thing that we're looking for. That's the thing that we're looking for. And then we have this other unknown, T1. So now we have two equations, two unknowns. This is now solvable. So one thing I can do is I'll go ahead and divide both sides. So let me just write down that first equation here. So what I'll do with that first equation is I will get my page all realigned. So I'll divide by this, 120 plus R sub W, divide that on both sides. So they cancel on the right, and now I know that T sub 1, right, because that would leave T sub 1 equals 200 over 120 plus R sub W. Okay, so what I'll do now is I'll take this thing and I'll plug it in for T sub 1. So that would create this equation, 200 equals 120 minus R sub W times 4 minus 200 over 120 plus R sub W. Okay, and we're solving this for R sub W. So maybe I'll go ahead and just distribute this piece through. I mean, another thing I could do is right here, multiply both sides by 120 plus R sub W. Maybe I'll do that. So I'm going to multiply actually both sides by 120 plus R sub W. you know what? I'm having second thoughts about that. So let's just FOIL this out. So 200 equals 120 times 4 is 480. Right, so I'm taking this times that to get 480. I'm FOILing this basically. That outside term, 120 times 200, would be 24,000. So I have plus negative 24,000 over 120 plus r sub w, right? So that's this times this. The inside combination, we get minus 4r sub w. And then the last combination, I get plus 200r sub w over 120 plus r sub w. Okay. So now what I'll do is do that multiplication that I was thinking about earlier. So I'll go ahead and multiply both sides by 120 plus r sub w. Basically, I'm doing that so I get rid of this fraction. What I do to one side, I have to do that same thing to the other side. Kind of running out of room, so I'll just squeeze that here. 120 plus r sub w. I'm multiplying that by 200. So I have 200 times 120 plus r sub w. That's the left-hand side now, after I multiply these. I still need to distribute, but... And then I'll have, if I distribute this thing, 480 times 120 plus r sub w. Here, my 120 plus r sub w's would cancel, right? So I'll just be left with the negative 24,000. Here, I'll just attach, so minus 4r sub w times 120 plus r sub w. And then here I get a cancellation, so I just am left with plus 200 r sub w. I need another piece of paper to continue this one. Okay, so now I want to multiply this out. So I'm actually going to do these distributions now. So 200 times 120 is still 24,000 since the last time I checked. So 24,000, and then distribute the 200, so I have plus 200 r sub w equals, I'm distributing the 480. That's 57,600. And then plus 480 times r sub w minus 24,000. And then I have negative 480 r sub w, right? I'm distributing this now in. And then I still have this minus, well, I need to distribute here too, minus 4 r sub w squared. And I still have this plus 200 r sub w. So here's our equation. Let's see what's going on. I have 480 r sub w. I have a negative 480 r sub w. So actually these cancel. I have a 200 r sub w on both sides. So when they're the same on both sides, it's like having opposites on the same side. So I can cancel those. I'll bring this negative 24,000, I'll bring that over. Try to create my 0. Okay. So 0 equals 57,600 minus, this would be negative 48,000, right? And then I have minus 4 r sub w squared. Just making sure I have everything accounted for. It looks like I do. I can go ahead and take this difference. So 57,600 minus 48,000. It's 9,600. So 0 equals 9,600 minus 4 r sub w squared. So what I'm doing is trying to isolate r sub w squared so I can take a square root. So maybe I'll add 4 r sub w squared to both sides. So 4 r sub w squared equals 9,600. Divide by 4. So 9,600 divided by 4 is 2,400. So I have now r sub w squared equals 2,400. And take a square root. Plus and minus technically, but then I'm eliminating that minus. So the rate of the wind is the square root of this number, which is this, apparently. So it's about 48. So I'm going to leave it in exact form. So 20 root 6, and that would be a number of miles per hour. For your information, it's almost 50 miles per hour, but I'm going to leave it in exact form since it didn't say anything about rounding. Not a simple problem, I realize. Okay. So number 15, it says 2 gardeners can do the weekly yard maintenance in 8 minutes if they work together. The older gardener takes 12 minutes more than the younger gardener to finish the job by himself. How long does it take for each gardener to do the weekly yard maintenance individually? So basically we have, if we let like X equal the young and Y represent the older, then I would have basically that the younger person gets one job done, and this is a time, by the way, time. The younger person gets one job done per some amount of time. If I add, the older person gets that one job done in some other amount of time, but if they work together, in other words, if we add their work together, then they get that one job done, let's see, in 8 minutes. Okay, so we'll have 1 over x plus 1 over y equals 1 over 8, right? Because this is them working together. There was a relationship between the older and the younger. So y, from that relationship, the older gardener, if I take x and then add 12 minutes more than the younger gardener. So if this is the older person's, this is the younger person. If I add 12 to the younger person, then I get the amount of time for the older person. So I can now take this and replace y with it. So 1 over x plus 1 over x plus 12 equals 1 over 8. Clearing the fractions is your next move. So the least common denominator of all these fractions would just be the product of all the fractions, actually. So 8x times x plus 12. This will be my LCD. So I'll multiply both sides by that. So I'll have 8x times x plus 12 times this whole thing on the left, 1 over x plus 1 over x plus 12. And then same thing on the right, I'll have 1 over 8, but then times 8x, x plus 12. And now I'll actually carry out the multiplications. So when I distribute this, right, this thing is getting distributed here and to there. When that first distribution happens, the x cancels away. So we're just left with 8 times x plus 12 actually. When this second distribution occurs, the x plus 12s cancel. So I'm just left with 8x. On the right, the only thing that cancels are the 8s. So I'm left with x times x plus 12. And now I'm solving this for x. So 8x plus 96 plus 8x equals x squared plus 12x. So it looks like I have 16x plus 96 equals x squared plus 12x. I want my 0, so I'll subtract stuff. Okay, so everything cancels on the left. I get my 0. So x squared minus, so 12x minus 16x is negative 4x, and then minus 96. Right? Quadratic formula, I would use a of 1, b of negative 4, and c of negative 96. So x would equal the opposite of negative 4, which is 4, plus and minus the square root of negative 4 squared, minus 4 times a times c, all over 2 times a. So fraction 4 plus root. So this will be negative 4 squared minus 4 times 1 times negative 96 over 2. So it looks like I get a 12 for the plus case. And that would be a number of minutes. For the minus case, let me see if that makes any sense. Negative 8 does not make sense. So we're counting time, so that one actually gets tossed out. So the younger person apparently takes 12 minutes to do the yard work on their own. To find the older person, I just need to add 12 to x. So I'd have y equals 24 minutes. All right, on number 16. It says the area of a triangular flower bed in the park has an area of 120 square feet. The base is 4 feet longer than twice the height. What are the base and height of the triangle? Meaning what lengths are they? So there's some kind of triangular flower bed here. And I know that this interior area is this 120 square feet. And if I call this B, the base of the triangle, I would call this the height, H. So the area of these triangles is always 1/2 the base times the height. And I know the area that I want to achieve is this 120. So I'll plug in that 120 and solve this for B and H. However, there are too many unknowns, right? We need to eliminate one of our unknowns. And that was given in this sentence here. So it said that the base, B, is 4 feet longer than twice the height. So I'd have B is double the height, and then I need to add 4. Okay. So instead of B, I can write 2h plus 4 right there. So 120 equals 1/2. Base is now 2h plus 4, and h is still h. So now I just have one unknown. Okay. So I'll go ahead and solve for h. So distribute the 1/2, distribute the h. So 120. Maybe I'll distribute the 1/2 first. Half of 2, that'll just leave an h. Half of 4, so I'll have 2. Still times h. So 120 equals, if I distribute this now, of course, h squared plus 2h. Solve for h. Subtract 120. So I get 0 equals h squared plus 2h minus 120. I need to solve this for h. So I'll use the quadratic formula. I'll say a is 1, b is 2, c is negative 120. So h would equal the opposite of b, plus and minus the square root b squared minus 4 times 1 times negative 120, all over 2 times 1. Okay, so might be easier to see over here. All right, so negative 2 plus square root 2 squared minus 4 times 1 times negative 120 over 2 times 1. So I get a 10. So kind of the plus case, if you want to notate it that way, you can, is 10, and that would be a number of feet. The minus case might not make much sense. If it's a negative height, then we're not going to use it. So yeah, that minus case gets thrown out. This is the only one we care about over here, right? H equals 10. So we just found the height. To find the base, I need to double the height and then add 4. So B would equal 2 times 10 plus 4. In other words, 24. And these are both feet. Okay. All right, here's number 17. It says a rectangular table for the dining room has a surface area of 24 square feet. The table length, or the length, is 2 more feet than twice the width of the table. Find the length and width of the table. So I'll draw this rectangle. I know that I'm aiming for 24 square feet in here. If this is the length and the width, there was a relationship defined between the length and the width. So it said that the length is 2 more feet than twice the width. So twice the width and then 2 more. So an area of a rectangle is length times width. The area that we want to achieve is 24. And now these 2 unknowns are present, but we can eliminate L by writing 2W plus 2. So I'll take this and plug it in for L. So 24 equals 2W plus 2 times W. So 24 equals, if I distribute here, 2W squared plus 2W. And then I'll subtract 24 to get my 0. So 0 equals 2W squared plus 2W minus 24. I'm noticing that everybody has a factor of 2. I'll just divide out that 2. just to make things a little bit more manageable. We have 0 equals w squared plus w minus 12. I'm now noticing that this thing looks like factors. So maybe I'll quickly factor this if that's okay. If you're getting quicker at this, you can definitely pick up the pace on the factoring if you want, but this looks like the factorization to me. So it must be that 0 equals w plus 4 or 0 equals w minus 3. Sorry. So solving for w, looks like I get a negative, so that one's actually going to be thrown away. But this one looks good. So I'm getting 3 equals w. This one, I'd be getting negative 4 equals w, but that doesn't make sense because w is a width. It's not going to be negative. So this is our width. To get L, I plug that in here. So L would be equal to 2 times 3 plus 2, in other words, 8. And these are both a number of feet. Okay. On to number 18. All right, anybody else tired? Okay, here's number 18, we're almost there. So graphing now, it says find the vertex. So when you have a parabola or an equation that's quadratic, such as this one, in general, if you have f of x equals ax squared plus bx plus c, then the vertex will be at opposite of b over 2a, and then f of opposite of b over 2a. So that's what I'll use here. I'm seeing that a is 2 and b is negative 4. So opposite of b over 2a for this one means opposite of negative 4, which is 4, over 2 times 2. And then I need to find f of 4 over 2 times 2. This simplifies to 1 and f of 1. So f of 1, I need that for the y component of the vertex. I can plug in a 1, so I get 2 minus 4, negative 2, minus 6, negative 8. So it looks like 1, negative 8 for the vertex. Okay. Find any x-intercepts. So let me just plot the vertex maybe first. So 1, negative 8. This one has a positive a value, which means this parabola will open up, and this vertex is sitting at what is now a minimum. So for sure there will be 2 x-intercepts. Just by the geometry, I know it's opening up, so I'm expecting 2 x-intercepts here. So I'll let f of x equal 0 and solve. So 0 equals 2 x squared minus 4x minus 6. Looks like everybody has a 2. I'll eliminate that 2. So 0 equals x squared minus 2x minus 3. It may factor. I'll just use the quadratic formula with a equals 1, b equals negative 2, c equals negative 3. So x equals opposite of negative 2 is 2, plus and minus the square root. Negative 2 squared minus 4 times 1 times negative 3. All over 2 times 1. Calculator. So I'm getting a 3 for the plus case. And then scroll back left. -1. So my intercepts, just to write them as points, would be 3, 0, and -1, 0. Okay, so I can actually go ahead and plot those maybe. So 3, 0, and -1, 0. Part 3 wants me to find the y-intercept. Okay, so what I do is let x equal 0 this time. So f of 0 would be equal to 2 times 0 squared minus 4 times 0 minus 6, which is -6. So as a point, we have 0, -6 as the y-intercept. So plotting that, 0, -6. I know that there's a symmetrical vertical line through the vertex always. So since I need to plot at least 5 points, here's 1, 2, 3, 4. But right when I identify this point, I know there's a symmetric point right over here across that axis of symmetry. So here's that parabola. All right, on to number 19. So find the vertex, again, that opposite of b over 2a. I have a is 1, b is 1. So opposite of b over 2 times 1, and then I need to find f of opposite of b over 2 times 1. So this simplifies to -1/2, and then I need to find f of -1/2. So I can say, all right, -1/2, can maybe press enter, and then what I can do is reference that. So I'll say answer squared plus answer, right? I'm plugging into here now, minus 6, and this will tell me that y component of the vertex. So we have a fractional vertex this time. It's -1/2, comma, -25/4. So just do your best when it comes to plotting that. So -1/2 right here, -25/4, about -6.25. So here's -1/2, -6.25, right about there. This one again is opening up, right? We have a positive a. So since our vertex is below and this thing is opening up, we will expect 2 x-intercepts. So I'll let f of x equals 0 and solve. So 0 equals x squared plus x minus 6. Factoring, -6, trying to add up to a 1, 3, and -2. This is a case where our a is 1, so I could quickly write the factorization as x plus 3 times x minus 2. Remember, when there's a 1 for a, as soon as you find the factors here that work, they will always just appear in the factorization this way. So it must be that x plus 3 equals 0 or x minus 2 equals 0. So in other words, -3 and +2. So x equals -3, x equals 2, but you do want to write these as a point typically. So -3, 0, and 2, 0. The x-intercepts for this one, I'll go down here and plot those. So -3, 0, and 2, 0. Part 3 wants the y-intercept, so I'll let x equals 0 for that one. So f of 0 equals 0 squared plus 0 minus 6, in other words, -6. the y-intercept is not always -6. These two, they both have y-intercepts of -6, but that's not always the case. I'll plot this. So just to the right, a half to the right, we get -6. That means a half to the left of the vertex, we also get -6. So that would be my 5 points. Sorry. So 1, 2, 3, 4, 5. And that's the practice exam. All right. Good luck, you guys.